In this example, you're asked to solve the equation cube root of 5 to the negative x power is equal to 1/5 to the power x plus 2. For an equation like this, you could solve by taking logarithms of both sides, and you'll look more into that method of solution later. Taking logarithms of both sides is a strategy that will work to solve most exponential equations. But with this one, I want to emphasize a different strategy that you can use sometimes. There's a property of exponential functions that says if a to the u equals a to the v, let's say. So if you have same base on both sides, then it's fair to assume that those exponents are equal to each other. And that's called the one-to-one property of exponential functions. But so the idea is if you can express both sides of the equation as powers of the same base, then, and only then, only when it looks exactly like this, so single exponential expression on both sides with the same base, then you can drop the bases and just set those exponents equal to each other and solve from there. So in this problem, it would be nice to express both sides as powers of 5. 5 to the something equals 5 to the something, and then drop the bases and set those exponents equal to each other. All right, so starting with that given equation, and I guess I'm going to go through several properties of exponential expressions as we go here. The first thing I'd like to point out is when you have roots, so I'll say the nth root of, let's say, x, can also be expressed as x to the 1 over n. So the square root of x, i.e. Square root of x is equal to x to the 1/2, and cube root, in this case, cube root of 5 is equal to 5 to the 1/3. So the first thing I'm going to do with that given equation is express the left side as 5 to the 1/3. And then you still got that negative x outside. Now, with that 1/5, I guess I'll introduce another property. So I'm going to box up these properties as I list them. 1 over x is equal to x to the negative 1. Or more generally, 1 over x to the power p is equal to x to the negative p. And let me box up that property. So in that way, we can change 1/5 to 5 to the negative 1. And that's still raised to the x plus 2 power. Okay, one last property, and I'm going to squeeze it on this page. X to the a raised to the b power is equal to x to the a times b. Let me box that one up. So we can use that in this next step. 5 to the 1/3 raised to the negative x. We can multiply that. And to multiply it, by the way, you should multiply straight across. You can look at that x, or that negative x, as negative x over 1, and multiply straight across. So 1 times negative x gives you negative x over 3 times 1. So the product there is negative x. Oops, I meant to have that in black. Negative x over 3. Same deal over on the right side. So you have negative 1 times x plus 2, and you should multiply the negative 1 times that whole expression, x plus 2, so it should distribute to both parts here. So you have 5 to the negative x minus 2 when you distribute that negative. Notice now that you do have just a single exponential expression on both sides with base 5. I don't want to squeeze my solution on this page. I'm going to try to be a little bit neater here. I'm just trying to memorize what I see there. Not the greatest planning once again here, but 5 to the negative x over 3 is equal to 5, I did remember it, to the negative x minus 2. Okay, base 5 on both sides, so now we're allowed to drop the bases and just say negative x over 3 is equal to negative x minus 2. And now to solve for x, I would first clear the fractions, or the fraction, by multiplying everything by that denominator 3. So that's legal as long as I multiply everything over here times 3. So make sure you distribute the 3 to both parts here. So the 3's cancel, that'll leave negative x on the left side. Distribute the 3 on the right side and you have negative 3x minus 6. Now combine the x's. So you have positive 2x equals negative 6, and divide both sides by 2. X equals negative 3.